Hi everyone, welcome back to my channel. My name is Lloyd. In today's video, I break down the four most misunderstood backend concepts such as reverse proxy, forward proxy, load balancer, and API gateway. Subscribe to the channel if you haven't done that yet. Make it safe and enjoy this video to the end. Now, let's look at some of the problem that reverse proxy, forward proxy, load balancer, and API gateway is solving. The first one we'll look at is the doorman problem. Imagine you walk into a 5-star hotel. There are 10,000 guests, 50 floors, 5 restaurants, a spa, a gym, and a casino. Now the question is, who decides where each person goes? The doorman, right? One person routing thousands of people every single day. That is exactly what happens every time you open Netflix, Google, or Instagram. By the end of this video, you will understand what each one does. And I promise you, this will completely change how you think about the internet. Smash that like button if you want to level up your system design. Let's look at the problem. Reverse proxy, forward proxy, load balancer, and API gateway. Why do we even need them? You understand why we need them in this video. Before we dive in, let's understand why they exist. Here are the raw, ugly truth about the internet. When you build an app, a web app, you deploy it on one server. The next day, there are 1 to 10 users. That's beautiful, right? People are using your app, and so you are so happy. Then the next 30 days, your app goes viral. Yeah, the internet did a thing. Social media, Twitter, Facebook, app all of a sudden blows up. And you have 500,000 users hitting your server at the same time across the globe. That's a lot, right? All of a sudden, your app server dies due to the high traffic. Your app then crashes. Your users can no longer access your app. That is called a single point of failure problem. Yeah. And it is the nightmare of every backend engineer. Just understand this truth. So let's look at the 4 problems that are exactly what our doorman solves. Let me introduce them, The number 1 is privacy concerns. So users don't want their identity exposed. So the doorman directs each and every individual to where they are supposed to be. Number 2 is security threats. Hackers target your server directly. Slow APIs, like when your server crashes. You have 10 different backend services all doing like different things. And then global users, someone in Tokyo is hitting your server in New York. That's amazing, right? Let's start with forward proxy. This is the one most people actually confuse with everything else. Forward proxy. A forward proxy actually sits in front of the client. Now the client talks to the proxy. The proxy talks to the internet. So you have a client sitting in front of their computer. They enter www.netflix.com. Now the client is not interacting with the internet, but then it is what? Or the server. But then it is what? Talking to a proxy. So when it comes to forward proxy sits in front of the client. And the client talks to the proxy. The proxy talks to the internet. And the internet never sees the real client. Now let's look at the real world analogy. Imagine you want to send an anonymous letter. So instead of mailing it yourself, you give it to a friend who mails it for. Now the recipient gets the letter but only sees your friend's address. You are anonymous. That friend is the forward proxy. Hope this analogy makes sense and it's simple for you to understand. Now, where do you see this in real life? Forward proxy. Where do you see forward proxy in real life? Corporate networks. Your company routes all your employee internet traffic through a proxy to monitor user usage, and in some organizations they block social media access. So if you're in a company, you cannot access social media platforms on your work network. Then we also have VPN. So when you use a VPN, you are essentially using a forward proxy, bypassing geo restrictions. So you can basically access content not available in your country. So these are some of the ways we see forward proxy in real life. Now let's look at some key characteristics of forward proxy. So one of the characteristics of forward proxy is that it protects client identity and it also controls outbound traffic, can cache requests that speeds up user query. The next time the user goes back to search for the same information on the internet. And finally, can enforce access what policies. So forward proxy can enforce access policies. You are not supposed to access any content or some content on your network. Forward proxy has the capability to enforce those. Now that we understand what forward proxy is, let's look at what a reverse proxy is. Now with a reverse proxy sits in front of the server. So remember we said forward proxy sits in front of the client. Okay, the client sits in front of the reverse. So with forward proxy, we say what? The forward proxy sits in front of the client. And with reverse proxy sits in front of the server. Note the difference very well. Now, clients don't know which server they are actually talking to. They only see the proxy. Let's look at the real world analogy like we did for forward proxy. Okay, when you call a customer service hotline, for example, you dial one number, but behind the scenes, there are about 200 to 500 agents. Now, the call center system will route you to the right agent. You never really dial an agent's number directly. What you did here was to just dial one number, and behind the scenes, the call center agent routes you to the right agent, or the call center system routes you to the right agent. You never dial an agent directly. The call center is the reverse proxy. Okay, so in this instance, the call center is the reverse proxy. Why would you use reverse proxy? Number one, reverse proxy hides your backend service. Okay, it hides your backend service. So hackers can't really target what they can't see. If a hacker doesn't see something, they can't target it. They only target what they can see. So with reverse proxy, you are hiding your backend service. Now, SSL termination. Reverse proxy handles HTTPs in one place instead of every server. There is also caching. Okay, caching. Now, reverse proxy serves static content without hitting your backend at all. And finally, compression. So reverse proxy compresses responses before sending it to the client. The most popular reverse proxy tool that most DevOps engineers use is Nginx. Okay, Nginx is one of the best reverse proxy tools in the world of DevOps. So this is exactly how companies like Cloudflare work at a massive scale. Every website behind Cloudflare is behind a reverse proxy. Now, what are some of the key characteristics of reverse proxy? You can talk about reverse proxy protecting your server's identity. Also, there is an SSL termination, SSL TLS termination. You talk about caching and then compression. And then you also talk about single point of multiple backends. Okay, so these are some of the characteristics. Now, we've looked at forward proxy, we've looked at reverse proxy. The next thing that we'll look at is load balance. And somebody may ask, what is a load balancer? Okay, now, so let's take it in this way. Okay, so now you've hidden your servers with a reverse proxy. But what happens when you have like 1 million users? One server still can't handle it, right? You need to scale. If your users move from 500,000 to 1 million users, one server cannot handle this user traffic. So what you need to do is to scale. You need to scale your service. And that's when load balancer comes in. Now, a load balancer distributes incoming traffic across like multiple servers to ensure no single server gets overwhelmed. Now that you understand what a load balancer is, okay, let's look at how load balancer works with an example. So imagine you are at the theme park. There are 10 ticket booths. A staff member at the entrance directs you to the booth with the shortest line. That staff member is the load balancer. Okay, now let's look at some load balancing algorithms. And these algorithms work to ensure that there is a proper distribution of incoming traffic across the multiple servers. Now, the first one and this is where it gets interesting. Somebody will ask, how does the load balancer understand which server it needs to route the traffic to and which server it does not need to route traffic to? And that's where the algorithms comes in. So let's look at some of the algorithms. The first one I'll look at is the round robin. With round robin, the load balancer sends the first request to, let's say, server one. Okay, in this instance, you have two servers. The algorithm that your load balancer is using is round robin. Now, the load balancer sends the first request to your server, your first server, which is server one. The second request goes to server two, and the third request goes to, let's say, server three. Okay, so you now have like three servers, and the cycle continues. That's like simple. So with round robin, every request that comes is being directed to servers in that cycle. So the first server gets the traffic, the second server, the next traffic that comes goes to the second traffic, and then the third traffic that comes is being redirected to then the cycle continues in that regard. The second algorithm that we'll look at is list connections. With list connections, the load balancer always sends requests to the server with the least number of connections or the requests. So assuming you have three servers and all of them are receiving traffic at the same time. Okay, with list connections, what happens is that the load balancer always send the request to the server with the least number of connections. That's the least number of traffic. And now that's some sort of smart way of thinking, right? The third one is IP hash. And what is IP hash? So with IP hash, the load balancer hashes an IP, okay, a particular IP, and it constantly serves that IP with a particular customer request. So let's say you have an organization in US and you have a branch in London. Now, if you want your customers who are in London not to access or direct traffic to your main headquarters in the US, you configure your load balancer to direct all traffic to customers who are based in London to only access resources in your London office. And that's what IP hashing is. So basically, the load balancer hashes the IP and sends it to one of the servers. The customer request always goes to that particular server. And the fourth one is the weighted round robin. So assuming you have two servers, okay, server A is very, very powerful with enough resources. And assuming you give it 70% of the traffic, and then server B is kind of like has lower resources. Now you always give you also give server B a 30% of the traffic. Now this is where it gets interesting. Again, the load balancer will always send a request to the best server with many resources, which is server A. It only directs traffic to the server with the highest priority, and in this regard, we give highest priority to server A with a 70% to traffic and then 30% to server B. And then the fifth one is geographical algorithms. Now, with geographical algorithms, the load balancer sends the request based on a particular region. So you can limit the load balancer to a specific region close to the customers. It is different from IP hashing. And for instance, it is useful for global services and latency reduction, even though they have some sort of similarities, but they are not the same. The final one is consistent hashing. So with consistent hashing, the load balancer uses a hash function to distribute the data across different servers. And that's how the load balancer works. Okay, so load balancer, based on what you are trying to achieve with your load balancer, these are the algorithms that you can consider. And let me just go over them quickly. We have the first one, which is round robin. The second one is list connection. Third one is IP hashing. And then weighted round robin, that's 4. And then fifth one is the geographical algorithms. And finally, the sixth one is the consistent hashing. So now let's look at some key characteristics of the load balancer. So one, load balancer distribute traffic across servers, which I mentioned earlier. And then it also handles server failures gracefully. In an instance where you have multiple servers that are receiving traffic from customers, and one server goes down, the load balancer uses the algorithm to redirect traffic to the server that is actually online. And so that's why we say it handles what server gracefully. And then also multiple algorithms for different needs. So with load balancers, you can configure multiple algorithms for what? For different needs. And then we also have key characteristics is that it enables horizontal what scaling. So load balancer enables what horizontal scaling. You can actually scale load balancer horizontally. That now that we understand what load balancer is, its algorithms and how it works properly, let's look at how to avoid single point of failure. You've always heard about single point of failure, single point of failure. How do you avoid it? So what load balancer does is that as a system thinking person, one of the things you need to consider when you are setting up or implementing a load balancer in any project that you are working on is to ensure that you add redundancy to the system. That is, you can add more than one load balancer to the infrastructure. So when one load balancer goes down, there is another load balancer that could handle the requests and distribute the traffic evenly. So you always need to ensure that you add redundancy to the system. And that's you adding more than one load balancer to avoid a single point of failure. Some other things that you can do is health check and then what? Monitoring. So that's all about load balancers. Now, let's look at API gateway. Now that we get to my personal favorite, API gateway. Every DevOps engineer's personal favorite is API gateway. If you think you have your personal favorite, you can comment in the comment section below and let me know what your personal favorite is. But for me, mine is API gateway. So this is the most powerful, most intelligent of the four tools that we've looked at. And what separates a basic app from an enterprise grade system? That's the API gateway. So an API gateway is a single entry point for all your microservice applications. And it is not just routing traffic, it is doing some kind of like smart things to that traffic. Let's look at the real world analogy. Okay. Think of a smart receptionist at a giant corporation. They don't just direct you to the right department. They check your ID first, log your visit, translate your request into the right language if you speak some kind of like a different language. They also do what we call rate limits on how many times you can visit and even cache your requests. So if they've seen your data that, okay, you often visit this particular hotel, then what they do is that they cache your requests if they've seen before. So what does an API gateway do? Okay, let's look at some of the things that you can use API gateway for. Authentication and authorization, that's number one. So you can use API gateway to check for JWT in full, meaning JSON Web Token before requests reach a particular service. You can also use API gateway for rate limiting. That's block users who make too many requests to a particular service. And then also request routing. So you can use API gateway to route to the right service, user service, and can also route you to the payment service. So for instance, if you have like different service, there's a user service, there's a payment service. You can use API gateway to do a request routing to a particular service. And also there is protocol translation. So let's say like translating a REST API to a gRPC and also translating HTTP to a WebSocket. API gateway can also do that. And then we also have request and then response transformation. So request response transformation allow you to kind of intercept a traffic and modify the traffic headers like payloads or protocols before they reach a service, or sometimes return to the client. So it is commonly used to inject authentication, standardize APIs, and enable, let's say, backward compatibility, integrate with what legacy system without changing any core service. So API gateway is one of the smartest tools that you can use in your infrastructure. And then finally, logging and monitoring. So you can use with API gateway, you can set up logging and monitoring to provide like a unified view of your system behavior. That's by collecting and correlating logs, metrics, and traces in a centralized platform using tools like, let's say, Prometheus and then what? Grafana. So real world usage of API gateway. So you can use AWS API gateway, which powers like millions of serverless APIs on AWS. There's another one called Corn. I think Corn is open source, and he also has like an enterprise grade where you can subscribe. Then we have the RPG. RPG is for Google, and it is used by large enterprises. And then finally, we have Azure API Management, which is Microsoft's solution. So, what are some of the key characteristics of API Gateway? So, API Gateway has serves as a single entry point for microservices. When it comes to authentication and authorization, API Gateway has that characteristics, and then also rate limiting and then throttling, and request transformation and routing, and then finally observability and then what? Logging. So, hey, if you made it this far, thank you for watching. If this video help you, click on the like button right now. It literally takes 1 second, and so subscribe if you want more system design content, and comment which of the four concepts was new to you, and how did you understand it, and how has it helped you. I'll read every single comment and then response as soon as I can. See you in the next video.